All right, so number 2, go ahead and set up your augmented matrix. Okay, so we have it set up, and we have the one in the top left corner like we like. But the only thing that's bothering me as I'm looking at this is I know I've got to have ones in this diagonal, right? But I've got a 0 in there. And I don't like that.
Switch it.
So yeah, let's switch it. So let's actually switch it with row 3 because we're going to need a 0 in the second column on row 3, aren't we? Yeah, so, which it may end up disappearing in our work, and then we have to get it back again, but, so let's go ahead and switch those two. So we're going to,
Yeah, why would?
I guess you could.
Because then it was 1, 1.
Okay. It doesn't matter.
Which was easier?
It doesn't matter, really, because we need ones right here, and we're going to need zeros down here. So that's why I was thinking bring it down, because there's a chance it could stay as a 0. It may change, but it may not. So that's why I was thinking bring it down. But you could definitely take it up too, okay? So I'm going to go ahead and just switch row 2 and row 3, and let's see how that works out for us with that 0 down there. So row 1's going to stay the same. And 2 and 3 are going to switch. Okay, so let's quietly go ahead and get those zeros that we need in that first column. So let's make both of these zeros. Jessica, that should be a -4 right there. Let me fit it in there properly. Okay, so what now? Yeah, we got to make that 2 into a 1. So we're going to multiply it all by 1/2. And I'm not going to write out the work step on this one. First row doesn't change. I'm going to do my third row because it doesn't change. And then multiply row 2 all by 1/2. So 0 times 1/2. 2 times 1/2. -6 times 1/2. And 2 times 1/2. Okay, so now we need a 0 down here, correct? So I need to combine it with a 1 times row 2, because we're in column 2. Even though, guys, row 1 has a 1 there, we don't want to use row 1 because it also has a 1 in the first place. And if I combine it with a 0, it's going to give me a number there. So we don't want to use row 1. We're in column 2, so use row 2. All right, so let's do that silently. All right, so what's wrong with our answer? Here we have 0 equals 0, which means what? Infinitely many solutions. But we have a way to write that. So what we're going to do is that means that z can be any number, right? Because that's what that third column would have solved for us, isn't it? It would have been our z variable. So z can be any number. So we're going to let z equal z. Which I'm going to kind of box this even though it's not my final answer. Okay? If z equals z, then the column above it tells me that 1y minus 3z equals 1, doesn't it? This column right here. I'm sorry, I'm saying column, I meant row. That row right there. So I can solve that for y. My answer is just going to be in terms of z. So if I solve this for y, you're going to add the 3z. And so you get 3z plus 1. And then the row above that tells us that x plus y minus 10z equals -4. We know what y is. Y is 3z plus 1. And so we can solve for x in terms of z as well. So I combine my z's. In that last step, 3z minus 10z is negative 7z. Ma'am? Negative 4. Thank you. I'm just not liking that negative 4 today, am I? And then we'll move the z over. So I'll get positive 7z. And I'm going to move the 1 over, so it gives me minus 5. And so my solution is going to be that ordered triple. So I'm going to write it up here beside that last matrix that we wrote out. So it's our x, comma our y, comma our z. So anytime we have a solution that's infinitely many solutions, we need to write our ordered triple like this in terms of the z.